Okay, on to lesson 3. So far we have learned how to collect like terms with this new language called algebra that we're learning. Okay, so we've learned to collect like terms. We've learned to also collect like terms when there are brackets in our expressions. Okay, so we saw what rules we needed to follow when there was a minus sign in between two sets of brackets, for example, or two sets of expressions. Okay, so like I had mentioned in the previous video, make sure that you get the hang of that. And literally, everyone, this is just like learning a new language. It just takes practice, practice, practice. When you're learning a new language, you want to try to speak that language as much as possible. A lot of times people say that you learn the language much better when you go to a specific country, for example, and you're immersed in that language, you hear it all the time, and you're forced to speak it all the time. It's the exact same with math. Okay, so look at it the exact same way when it comes to algebra. If it's something where you're just going to look at and breeze by, you're never going to learn this language all that well. But if you force yourself to really go through it and repeat, 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 eventually, trust me, you will get the hang of it, and it will be as second nature as speaking English. Okay, but it does take a lot of work and practice. So far, we've learned how to handle expressions or simplify expressions like this. Well, today we're going to learn how to multiply polynomials. And then once we've multiplied, then we're going to use what we learned in the previous lesson and simplify it down to make it more efficient. Okay, so this is something we did in the previous lesson. So if I were to quickly answer this, I would drop the brackets on this first expression. And then to drop the brackets in the second expression, I would distribute my plus sign with the x. So I get plus x and then plus negative 5, which I know when I have a plus and a negative side by side, it becomes minus 5. So if I were to simplify this really quick, just something we did in the previous lesson, it would look like this. Drop all your brackets, distribute your positive sign through the second set of brackets, and now collect like terms. Okay, so you end up getting 3x squared, and then I have a minus 5x plus 1x. Okay, so negative 5 plus 1 is negative 4x, or minus 4x. And then plus 3 minus 5. So positive 3 minus 5 in your calculator is just minus 2. So that would simplify down, and you can't go any further than this because there are no more like terms. Well, in today's lesson now, we are no longer going to have a plus or minus sign like we have here in between two sets of brackets. Because in the previous lessons, we were adding and subtracting expressions. Now we're going to be multiplying. So you're going to see no sign there. Okay, you're going to just see brackets like an expression and then brackets, which means multiplication. Just like right here. Okay, if you saw 2 bracket 4, you should hopefully know at this point that this means 2 times 4. Okay, which is 8. So notice there's no plus or minus sign in between. Okay, there's a 2 and then a bracket and then a 4. Same thing here. 3 times 2x. Well, when you're multiplying a number times a number times x, like here we have 2 times x, all you need to do, it's actually pretty straightforward. You just need to multiply 3 times 2, so you get 6, and then just put your x there as well. So if you have 3 2x's, you have a total of 6 x's, 3 groups of 2 x's. So if I were to draw this out, I have 2x, 2x, 2x. I have 3 groups of 2 x's. Okay, that's what this means kind of as a drawing. So how many total x's do I have? Well, I have 6 x's altogether. Okay, so all you need to do is multiply 3 times 2 there to see that you end up getting 6x. Okay, now just off to the side, what if this had said, because this is a thing where students get really confused. So what if this had said 3 times negative 2x? See, a lot of students would think, oh, now I'm adding and subtracting. This is 3 minus 2x. But look closely at the difference. Do you see a sign in between the brackets? Is there a plus or minus in between the brackets? Or where the number ends off and the brackets begin? You do not see a sign. That is different than 3 plus negative 2x. These are different. Okay? This one means multiplication. This one means addition, of course. Okay? If you see no sign in between your number and your set of brackets, you really have to pick up on the fact that you are multiplying. You are no longer adding and subtracting. See over here in this example, and I'll just erase a little bit of what's here to clean it up. Okay? In this example, look what's in between the sets of brackets. A plus sign, right? That is addition. No sign in between means multiplication, like here. Okay? All right, so we know how to multiply something like a constant, like a 3 multiplied by a term with an x, like 2x. Okay? Now let's expand on that a little bit, and let's get a little bit more involved. What if we did 4 times, because remember there's multiplication in between the number and the sets of brackets. What if we did 4 times all of 2x plus 3? All of 2x plus 3. It's not just 4 times 2x, because look at what's in the bracket. It's all of 2x plus 3, and you're multiplying 4 by everything in the bracket. So what you do is you go, okay, 4 times 2x, okay, 4 times 2x simplifies to 8x, okay? And then positive 4 or 4 times positive 3, okay? Always look at that sign that is in front of that number, okay? If that were a minus 3, you would do 4 times negative 3. But because it's a plus 3, you just do 4 times positive 3, which is positive 12, or plus 12. Same thing. Now, always check if you can collect like terms after. Can you collect any like terms here? No. Okay, this is a number 12, and then you have 8x, which has an x in it. They are not like terms. You cannot go any further. Let's look at an identical example, really, except this time we have a negative 2 instead of a positive number out in front. Okay, so we actually have a negative number in front. Nothing changes. Now, what number is in front of this x that you don't see? It's a 1. Oop, kind of hard for me to draw in there. Okay, it is a 1. Okay, so just remember that. There's a 1 in front of the x. Okay, so it's 1x. So you would do negative 2 times 1x, or negative 2 times 1, which is negative 2x. So you would pull out your calculator there, and you would do negative 2 times 1, and you would get negative 2, and then just keep your x the way it is. So you have negative 2x. Then do negative 2 times positive 2 in your calculator. Negative 2 times positive 2. You get negative 4 or minus 4. Can you go any further? Can you collect like terms now? No. The answer is no. They are not like terms. We have an x term, and we just have a constant of the 4 there. Okay, so we cannot go any further. So let's recap there what we've learned, okay? So what we are learning here is something called, see how we are multiplying the 4 times everything in the bracket and the negative 2 times everything in the bracket? That is a mathematical rule, okay? Just like there's rules in learning languages, that's a mathematical rule called the distributive property. Why is it called that? Well, it's because you're distributing the 4, for example, you're distributing it into everything that's in the bracket, not just the first term in the bracket, but everything. And so that is called the distributive property. Okay? So at this point in the video, I suggest you practice these questions that I just did on a blank sheet of paper, cover my answer, and see if you got the same answer as I did. Okay, I strongly suggest you do that before you move on to this next part of the video, because we're going to get a little bit more involved in this next part. Okay, so pause the video and try these 4 questions that I just did. Cover my answers and see if you got it right. Okay, so we know now that when you are collecting like terms, you have to have like terms to add and subtract terms together. Okay, you have to have like terms to add and subtract terms together, meaning you have to have, like, if you're going to add together, if you're going to add terms together, they both have to be, let's say, they would both have to have an x, for example, and then you can add them, and that would be 7x. This is not the case when you're multiplying. Okay? When you're multiplying, you're not looking for any like terms. You do not have to have any like terms. Okay? You can simply multiply anything together. Variables that aren't like terms, numbers, it doesn't matter. You can multiply anything together. Okay? So you need to separate that in your mind, that when you're adding and subtracting, you have to use like terms. When you're multiplying, they do not have to be like terms. Okay? So watch this now, okay? How would you do, so let's say you had x times x. What would that equal if you had x times x? Well, let's forget about using x's right now, and let's say that we had 3 times 3. Okay, so the same number multiplied by each other, just like here with x's, the letters just really represent numbers. Okay, so let's say we had 3 times 3 there. What's another way you can write 3 times 3? Well, I mentioned it right here. You can write it as 3 squared. Okay, so what does x times x equal? It equals x squared. So it's just like you're multiplying 2 of the same numbers together, so you would just write it as squared. Okay, well, it's the same thing with variables. Okay, x times x is x squared. That is different. Okay, that is different. If I can erase this for a second. This is something you need to get clear in your mind. And in teaching this a lot, I know that students struggle with this a little bit. X times x is x squared. X plus x is what? Well, we know that there's a 1 in front of each of those, so x plus x is 2x. Look at the difference in the answers. You've got to be really careful, okay? Be very careful with not getting those two confused. X times x is x squared. X plus x, you have 2 x's, okay? All right, let's get a little bit more complicated from there. What if we have x squared times x? Okay. What if we have x squared times x? Well, let's break this down. Okay, let's see what this means. If you have x squared times x, think of how that would actually mean. Let's break down x squared. X squared could really be written as x times x, right? So x times x covers this portion of it, then times another x, so put another x there, times another x. What's a way you can write that out as? X times x times x. Well, what if I asked you, what's another way to write 3 times 3 times 3? It would be 3 to the power of 3. Well, in this case, it is x cubed, or x to the power of 3. Okay? So how did we do that? Well, let's think about this here. For the most part, I'm not going to ask you crazy difficult questions. Like, I mean, let's look at some of the examples. Sorry about that. Let's look at some of the examples I have here. Look at this. X times x, right? X times x. Let's see how involved this gets. X times x squared. Okay, another x times x squared, x times x times x squared. You can see that for the most part, I'm not going to ask you any more than x times x squared. Maybe at the most, I may ask you x squared times x squared. Okay, and let's look at what that would be if I asked you what x squared times x squared was. Okay, let's just do that. That's probably the most I would go with it. I mean, I don't think it would go any more than that. So especially on an assignment, I certainly wouldn't ask more than that. So if I have x squared times another x squared, let's break this down again. Well, the first x squared can be rewritten as x times x. The second x squared bracket can also be rewritten as x times x. Okay, so what's a simplified way of writing that? Well, again, I take you back to if we use numbers, 3 times 3 times 3 times 3. What's an easier way to write that out? It would be 3 to the power of 4, right? 3 times itself 4 times. Well, this is x times itself 4 times. Hopefully you're starting to see the pattern, everybody. How did we get x to the 4? If you look at your 2 and your 2 here, there's actually a rule called Exponent Laws here. The trick is you just add those together, 2 plus 2, and you get 4, and that gives you your new exponent. That's actually the little trick, okay? And if I were to go back to our previous example, okay, just clean all that up. If I were to go back to our previous example of x squared times x, if you just see an x, what exponent is really on that x that is never written? Well, if I were to say, like, if I just saw the number 3 and I said, what exponent is on that number 3 that you never write out, but it's just understood that it's there? It's a 1. Okay. Well, same thing here. When you just see an x, it actually just has an exponent of 1. Okay. So add the exponents. If you're multiplying x times x here, or x squared times x, just add those exponents and you get x cubed. Okay. 2 plus 1 is 3. Okay. Now that's just the shortcut way of doing it. You can do it the long way of kind of writing it all out. That's up to you. But let's get back to doing some questions here. So we are going to use the distributive property, which I explained above, to do x times x, which is x squared, and then do x times positive 2. Remember to use the sign that's in front of the 2. X times positive 2 is positive 2x, or plus 2x. Okay? Can we, now that we've gotten rid of the multiplication, we're down to just addition, okay? Can we go any further? Can we go any further? Can we collect like terms here? No. Okay, because now we're adding, no more multiplying, we're adding, there is no like terms there to combine or collect together. Okay? All right, next one. Negative 2x times x, okay? What does that equal? Negative 2x times x. It is negative 2x squared, okay? negative 2x squared. The x times x becomes x squared there. And then do negative 2 times positive 3. Negative 2x times positive 3. So in your calculator, do negative 2 times 3. You should get negative 6. But don't forget that it's negative 6x because this has a negative 2x there. So it's negative 2x times 3. Negative 2x times 3. Okay? So you get negative 6x or minus 6x. I strongly suggest pausing the video again and making sure that if you tried this by yourself, you would get those same answers. Okay, next question. This one gets a little bit more difficult, right? Let's do the first multiplication, the first distribution. Negative 4x times 3x squared. Negative 4x times 3x squared. Well, multiply negative 4 times 3. That's negative 12. And then what's x times x squared, right? We have an x here and we have an x squared there. That is x cubed. So negative 4x times 3x squared is equal to negative 12x cubed. Okay? Negative 4x times 2x. Negative 4x times positive 2x. Remember to always say the sign that's in front. Okay, negative 4x times positive 2x is negative 8. And then x times x, right? There's an x here and an x there, is x squared. Then lastly, negative 4x times negative 5. Negative 4 times negative 5 becomes positive 20. But don't forget the x because this had a negative 4x, not just a negative 4. So don't forget the x there. Okay, so negative 4x times negative 5 is positive 20x. Are there any like terms there? Right? We're done all the multiplying, so now we're down to just addition and subtraction. Are there any like terms? The answer is no. So we can't go any further. Box your answer. Okay, that's your final answer. Strongly suggest you try this question on your own again. Pause the video, try it again on your own after watching. Okay, I'm telling you this unit, after teaching it a number of times, this is a unit where it really requires you to practice. And it's not enough to just watch me do it. You need to do it over and over again. I can't stress that enough. Okay? Okay, we're down to the last two questions. These ones are a little bit tougher, of course. Okay? So, 2x times, so let's look at what we've got here before I actually get too involved. Let's look at what we've got here. So I've got a distributive property here and here, right? I have a term times a binomial. This is the binomial here. It's got two terms in it. Then I have a plus sign. Oh, okay, so this is different. I haven't seen this before. I have a plus sign in between, and then I have a distributive property again to distribute through. So I have a multiplication there. I have two different sets of multiplications. Let's take a look, okay? Let's do this one step at a time. 2x times x squared is 2x cubed. Okay, x times x squared is x to the power of 3. 2x times 3x. 2x times 3x, or positive 3x. It is positive 6x squared. Okay, x times x is x squared. Okay, now because that's a plus x, okay, bring down your plus sign. Bring down that plus sign right there. Okay, and now do x times 3x. What's x times 3x? 3x squared. Okay, x times 3x is 3x squared. And then, be careful here, x times negative x squared. Wow, okay, so x times negative x squared. Remember that if you do not see a number in front of your x, assume that it is a 1. So that's a 1x, and over here, assume that that's a negative 1x squared. So do 1 times negative 1. You get negative 1 on your calculator. 1 times negative 1 is negative 1. And then don't forget that you have to do the x times x squared, which is x cubed again. Okay? This is the hardest question we've done so far, without a doubt. Can you go further than this? Can we now that we've done the multiplication, we've gotten rid of all the brackets, can we now collect like terms? Let's see. Yes, we can. We have a 2x cubed and a minus 1x cubed. So let's combine those. Remember to take the sign that's in front. So minus 1x cubed. Then I have a plus 6x squared plus 3x squared. Okay, so we've got our like terms grouped together. Let's now just add and subtract. So 2 minus 1, or 2x cubed minus 1x cubed is 1x cubed. Okay, so like 2 cats minus 1 cat is 1 cat. And now positive 6 plus 3 is plus 9x squares. Okay, and there you have it. Our final answer then, I guess I won't write the 1 in front because it's not totally proper to do that. Here's our final answer. Okay. All right. Last question here. It's exactly like the question above, but I picked it on purpose because look at here. Here we have a plus sign. Guess what we have in the next question? Instead of a plus sign, we have a minus sign. Okay, so let's see how to handle something like that. Let's take a look. All right, so let's just erase what I've got there, clean it up. Okay, let's start. I've got 2 separate multiplications. Okay, I've got 2 separate sets of brackets being multiplied by something different. So I've got to do 2 separate multiplications here. This first one, I have to multiply 3 into every term in this bracket. All 3 of them. Let's do that first. 3 times x squared. 3x squared. Okay, and once I start multiplying, I can drop the brackets. That's the whole purpose of the multiplying, okay, is to drop the brackets and simplify. 3 times negative 5x. Okay, so I just want to write it as I go. 3 times negative 5x. Okay, 3 times negative 5x is negative 15x, or minus 15x. 3 times negative 6 is negative 18, or minus 18. Okay, so we dropped that first set of brackets because we got rid of the multiplication. Next, to do this question, okay, look at this 2x. Don't just look at it as a 2x. My strong suggestion to you is to look at it as a negative 2x times x squared. So use the sign that's in front. Negative 2x times x squared is minus 2, or negative 2x cubed. and then do negative 2x times negative 8 becomes positive 16x. Don't forget that x there, right? It's negative 2x times negative 8 is positive 16x. We now got rid of all the multiplication, and now this is like a question from last lesson, right? The lesson from 5.1 and 5.2. We've gotten rid of all the multiplication. Now we just have to collect like terms. So what like terms do I see? Okay, I see nothing with the x squared. I see nothing with the x cubed. But I do see this and this that are like terms. So I'm going to group those together, and then I'll add them in the next line. So let's go 3x squared minus 15x. Remember, use the sign in front, plus 16x. Use the sign in front of the 16. Then rewrite the rest. Minus 18, right? Minus 18, and then minus 2x cubed. Now, what's negative 15x plus 16x? Or what's negative 15 plus 16? It's positive 1, or plus 1x. Minus 18 minus 2x cubed. Can I go any further? No. Okay, none of those are like terms anymore. And just to finish this off, because I mean, I'm not going to be picky about this, so if you want to disregard this step, that's fine with me. But it's proper math, proper rules, just like there's proper grammar rules in different languages, that you don't leave it in this order. You actually leave it in the order of what's called the highest degree. This is your highest degree. So I'm just going to move that over. Instead of having minus 2x cubed at the end, I'm going to put negative 2x cubed at the beginning. Then I'll put the positive 3x squared there, okay, and that is a positive 3 here, okay. If you don't see a negative, assume it's a positive. So it's a plus 3x squared plus x, or 1x, and then minus 18. So you can disregard this last step. I'm not going to be picky about that, but you should put them in order of what's called highest degree to lowest degree. Okay, so the highest exponent to the lowest exponent. Okay, remember that the x here actually has an exponent 1. So look at how we put the exponents in order. Cubed, squared, 1. Okay, 3, 2, 1. Okay. Strongly suggest these two questions that I just did. You have my solution. Okay, you can rewatch the video and watch me do it step by step, but try it yourself 1 time, 2 times, 3 times, 10 times, as many times until you get it. Not to the point where you just get it and you just fumbled your way to it, but to the point that you've mastered it. If you've mastered these two questions, then try the homework. Okay, but until you've mastered these two questions that I just did, the homework is going to be a bit of a challenge. And I think you'll have a much easier time to just master these, because you have my video explanation. Master these and then move on to the homework questions.